The B-29 Superfortress program had begun as a technological gamble. It was the most expensive aviation project of the war, costing billions of dollars and employing tens of thousands of workers. The aircraft was designed for a specific purpose: to strike strategic targets at very long range, flying higher and farther than previous bombers. Pressurized crew compartments allowed missions above 30,000 feet. Remote-controlled gun turrets gave defensive firepower without exposing gunners to extreme cold. On paper, the B-29 could reach Japan from bases in China. Early plans relied on airfields around Chengdu, but supplying those bases required flying fuel and bombs. Over the Himalayas, the route known as the hump. Each gallon delivered to China often cost several gallons in transport. The logistical strain limited how much damage those missions could truly inflict. American planners began looking elsewhere on the map. The Mariana Islands stood out immediately. Saipan, Tinian, and Guam lay roughly 1,500 miles from Tokyo, within B-29 range for round-trip missions with meaningful bomb loads. If those islands were captured and developed, they could serve as unsinkable aircraft carriers deep in the Pacific. For Japan, that possibility was alarming. Losing the Marianas would mean the home islands were no longer beyond reach. It would expose industry, cities, and transportation networks to direct attack. It would also sever lines between Japan and resource areas in Southeast Asia. By early 1944, both sides understood the stakes. American shipyards were launching new carriers, transports, and escorts at a rate unmatched in history. Pilot training pipelines expanded. Radar improved fleet defense. Submarines were tightening a blockade that reduced Japan's merchant shipping month by month. Oil and raw materials were already becoming harder for Japan to move across the Pacific. The war was shifting from expansion to endurance. Japanese strategy still relied on a decisive naval battle that would weaken the U.S. fleet, enough to force negotiation. But that battle required holding key positions long enough for the opportunity to arise. The Marianas became one of those positions, perhaps the most critical, and among those islands, Saipan held particular value. Its size allowed multiple airfields. Its location made it a natural hub. Whoever controlled Saipan could project air power across a vast arc of the Western Pacific. By the spring of 1944, plans on both sides were converging on the same point on the map, even if neither side could yet see how profoundly that island would change the air war. Because once Saipan entered the calculations, distance stopped being a shield and started becoming a countdown. In June 1944, the countdown reached its final days. American planners designated the Mariana Campaign as Operation Forager. The objective was clear: seize Saipan, then use it to support further operations against Tinian and Guam. The invasion force assembled was immense: hundreds of ships, tens of thousands of Marines and soldiers, and overwhelming naval air support. It reflected how seriously the United States viewed the Marianas as a gateway to Japan itself. Saipan was not lightly defended. Roughly 30,000 Japanese troops were stationed on the island under Lieutenant General Yoshitsugu Saito. They were supported by artillery, tanks, and fortified positions built into the island's rugged terrain. Cliffs, sugar cane fields, and rocky ridges offered natural defensive lines. Japanese doctrine emphasized fighting to the last, and preparations reflected that expectation. Civilians were present as well. Thousands of Japanese settlers lived on Saipan, many brought there during the pre-war mandate period. Their presence would later deepen the tragedy of the battle. On June 15, 1944, U.S. forces began the invasion. Naval guns opened fire first, their shells slamming into coastal defenses. Carrier aircraft followed, striking artillery sites and strongpoints. Then the landing craft approached the beaches, carrying the 2nd and 4th Marine Divisions. The shoreline became a violent threshold. Machine gun fire and mortar shells met the first waves. Coral reefs complicated landings, forcing some troops to wade ashore under fire. Casualties mounted quickly, but the beachheads held. Reinforcements poured in. Supplies followed. The Americans pushed inland, yard by yard. The battle did not unfold as a single dramatic clash. It became a grinding contest of attrition. Japanese forces used caves and concealed positions to slow the advance. Night attacks tested American lines. Heat, humidity, and exhaustion shaped daily life for both sides. While the fighting raged on Saipan, events at sea added another layer. The Japanese combined fleet moved to challenge the invasion, hoping to trigger the decisive battle they had long sought. The result was the Battle of the Philippine Sea, fought June 19–20, 1944. American radar-directed fighters and improved pilot training proved decisive. Large numbers of Japanese carrier aircraft were shot down in what U.S. aviators later called the Great Marianas Turkey Shoot. The outcome weakened Japan's naval aviation severely. Many experienced pilots were lost, and carrier air power would never fully recover. The fleet itself survived, but its striking power was diminished. Back on Saipan, the ground battle moved toward its final phase by early July. Japanese resistance grew increasingly desperate as supplies dwindled. Command cohesion eroded. Communication with higher headquarters became uncertain. On July 7, 1944, Japanese forces launched one of the largest banzai attacks of the Pacific War. Thousands charged American lines in a final attempt to break through. The assault inflicted casualties, but ultimately failed. Many of the attacking troops were killed. Organized resistance on the island soon collapsed. The civilian toll was heartbreaking. Fear, propaganda, and the chaos of battle led many non-combatants to flee toward the island's northern cliffs. Some perished in the turmoil that followed. The human cost of Saipan extended beyond the battlefield and left a lasting scar on memory and history. By July 9th, Saipan was declared secure. The strategic consequences reached Tokyo almost immediately. The loss meant the American military could base long-range bombers within reach of the Japanese home islands. It also exposed weaknesses in Japan's defensive planning. Political shock followed military defeat. Prime Minister Hideki Tojo's cabinet fell in the aftermath, reflecting the gravity of the setback. For American engineers and construction units, the battle's end marked a beginning. Seabees and Army engineers moved on to the damaged airstrips. Coral was leveled. Runways were lengthened. Fuel storage, maintenance depots, and support facilities rose quickly from the churned ground. Saipan was transforming from a battlefield into a launch point. Aircraft that had once struggled to reach Japan from distant bases would soon fly from here with heavier bomb loads and more regular schedules. The distance from Saipan to Tokyo was still vast, but it was no longer prohibitive. The mathematics of air power had changed. Japanese planners understood what that meant. Even before the first bomber arrived, the map had already shifted in their minds. The homeland was entering the operational range of a new kind of air campaign, and as construction crews worked under the Pacific sun, the sound of engines would soon signal that the next phase of the war would be fought not only on islands and seas, but in the skies over Japan itself. The aircraft that would carry that phase forward was already waiting in numbers, built for altitude, range, and persistence. The B-29 was a machine of aluminum and rivets, but its limits were defined by the men inside it. A typical crew numbered 11. Pilot, co-pilot, navigator, bombardier, flight engineer, radio operator, and gunners. Each role depended on the others. At high altitude, survival itself required coordination. The pressurized compartments were a major innovation, yet they were not luxuries. They were necessities. Outside the fuselage, temperatures could fall below -40 degrees Celsius. Frost formed on unheated metal. Oxygen masks had to function flawlessly. A failed seal or a damaged line could turn a routine mission into a medical emergency. Crews trained repeatedly for decompression scenarios, rehearsing how to descend quickly without losing control or formation. Missions from the Marianas were long. 10 to 15 hours was not unusual. Fatigue accumulated quietly. The drone of engines never truly stopped. Vibrations traveled through seats and boots, through bones and concentration. Men learned to read instruments with calm precision because there was no room for panic at 30,000 feet. Letters home often spoke less about danger and more about distance. The Pacific below them looked endless. There were no landmarks, only calculations and headings. Navigators carried immense responsibility. A small error could mean missing Japan entirely, or reaching it without sufficient fuel to return. Combat losses were not abstract statistics to these crews. They saw empty revetments on Saipan, where aircraft had once stood. They attended briefings where familiar names no longer appeared on rosters. The human dimension of the B-29 campaign was measured in endurance, discipline, and the quiet acceptance that each mission stretched the margin of safety. And yet, the crews kept flying, because they understood that these flights were reshaping the war's geography. The B-29 Superfortress was not just a bomber, it was an integrated weapons system, one of the most complex aircraft of its era. Its range exceeded 3,000 miles under certain conditions. That figure alone altered strategic planning. For the first time, the United States possessed a bomber capable of reaching Japan regularly from secure bases. But range meant little without payload and survivability. The B-29 carried both. It could haul several tons of bombs while operating at altitudes difficult for many fighters to reach in 1944. Its remote-controlled gun turrets were directed by analog computers, allowing gunners to aim multiple turrets from sighting stations. This reduced drag and improved defensive coordination. But the aircraft was not flawless. The Wright R-3350 engines were powerful, yet temperamental, especially early in deployment. Overheating and fires were persistent concerns. Ground crews worked long hours refining maintenance procedures. Modifications improved cooling and reliability over time, but the reputation lingered among air crews. Radar bombing aids also began to play a role. Cloud cover frequently obscured Japanese targets. Instruments like the AN/APQ-13 radar allowed crews to identify coastlines and urban areas even when visual bombing was impossible. This marked a shift toward all-weather strategic bombing. The B-29 represented industrial depth as much as engineering ingenuity. Factories, supply chains, training schools, and maintenance units formed a network behind every mission. Each sortie reflected thousands of hours of labor far from the front lines. Technology, in this sense, became a multiplier of distance. It allowed the United States to project power across the Pacific in a sustained, methodical way. And for Japan, it introduced a threat that could not be countered by geography alone. For Japanese military planners, the fall of Saipan forced a reassessment that was both strategic and psychological. Pre-war doctrine assumed that distance and layered defenses would protect the home islands. The Marianas were considered a buffer. Losing them punctured that buffer. Maps in Tokyo headquarters suddenly looked different. Circles representing bomber range now touched the Japanese mainland. Intelligence officers tracked American construction on captured islands. A new runway on Saipan was not just an airfield. It was a statement of intent. Each completed strip suggested future raids, larger formations, and increasing frequency. Japan's air defense system faced structural limits. Radar coverage existed, but was not as extensive or integrated as that of the Allies. Fighter forces had skilled pilots, but attrition in earlier campaigns had reduced their numbers. Fuel shortages also constrained training and readiness. Commanders understood that interception at high altitude would be difficult. Many Japanese fighters performed best at medium or low altitudes. Reaching B-29 cruising heights required time, coordination, and favorable positioning. Even when interception succeeded, the bombers' defensive fire posed risks. There was also the issue of industry. Aircraft production competed with naval needs and ground forces. Replacing losses grew harder as raw materials tightened under blockade pressure. The reaction within leadership circles was not theatrical panic, but sober recognition. The strategic equation had shifted. The homeland was no longer a distant sanctuary. It was becoming a reachable target. And that realization framed every decision that followed, as both sides prepared for the next phase of the air war. The next phase would reveal how tactics, doctrine, and adaptation shaped what those bombers could truly accomplish. When B-29 operations from the Marianas began in late 1944, American planners initially emphasized high-altitude precision bombing. The doctrine mirrored earlier campaigns in Europe. The idea was to strike specific industrial targets, aircraft factories, steelworks, engine plants, and weaken Japan's capacity to wage war. On paper, the approach was sound. In practice, Japan's geography and atmosphere complicated it. The jet stream, a powerful high-altitude wind current, had only recently been studied. Over Japan, it often exceeded 100 miles per hour. Bombs released from high altitude could drift far from their intended targets. Formation flying became harder. Fuel calculations grew more complex when headwinds slowed progress. Cloud cover added another challenge. Japan's weather frequently obscured aiming points. Even with radar assistance, precision was difficult. Early mission reports showed that while some targets were hit, overall accuracy varied. Results did not always match expectations from pre-war planning. This forced reassessment. Analysts compared photographs, bomb damage reports, and crew observations. Gradually, commanders recognized that tactics designed for Europe needed adjustment in the Pacific context. Altitude, timing, bomb type, and approach routes all entered review. The process was methodical rather than impulsive. Each mission produced data. Each debriefing refined the next plan. The evolution of tactics did not reflect failure alone. It reflected adaptation. The B-29 campaign became a laboratory for modern strategic bombing under unfamiliar atmospheric conditions. And as tactics evolved, so too did the defensive measures on the ground below. Japan had prepared for air raids, but preparation did not guarantee readiness for their scale. Civil defense organizations existed in major cities. Fire brigades trained for urban response. Buckets, pumps, and neighborhood groups formed the backbone of early firefighting efforts. Some shelters were constructed, and blackout procedures were practiced. Yet, many Japanese cities were densely built, with wood and paper structures. This traditional architecture, while culturally rooted and practical in peacetime, increased vulnerability to fire. Urban planners before the war had not designed cities with sustained aerial bombardment in mind. Early warning depended on radar stations and observer networks. When incoming aircraft were detected, sirens could alert civilians. But warning time varied. High-altitude bombers approaching over water sometimes provided limited reaction windows. There was also a psychological dimension. For years, the Japanese mainland had been largely beyond the reach of enemy bombers. The sense of separation from the front lines was real. News of Saipan's fall and subsequent raids began to change public perception. The war was no longer distant. Government messaging emphasized resilience and duty. Civilians were encouraged to remain disciplined, to respond calmly to alarms, to support firefighting and recovery. Many did. Diaries and later accounts describe organized efforts to contain damage after raids. Still, each alert reinforced a new reality. The sky could bring war directly overhead. And behind every siren lay the logistical network that made those flights possible. The transformation of the Marianas into major air bases was one of the largest engineering efforts in the Pacific War. Seabees and Army engineers worked at a relentless pace. Coral and volcanic soil were leveled to create long runways capable of supporting heavy bombers. Fuel storage tanks rose beside taxiways. Ammunition depots, repair hangars, hospitals, and barracks expanded across previously contested ground. Everything required shipment across thousands of miles. Construction equipment, spare parts, food, aviation fuel, bombs, all moved through a supply chain protected by the U.S. Navy. Convoys and fleet logistics became as vital as combat units. By late 1944, Saipan and nearby Tinian supported dozens, then hundreds, of B-29s. The islands functioned like fixed aircraft carriers that could not be sunk. Their capacity grew month by month. This logistical depth allowed sustained operations. Aircraft could be repaired, rotated, and relaunched without the limits faced by carriers at sea. Crews could rest between missions. Training and planning facilities improved coordination. Logistics rarely captured headlines, but they determined endurance. The ability to maintain pressure over time mattered more than any single raid. And as the infrastructure solidified, the air campaign transitioned from experimental to persistent. The next missions would demonstrate what that persistence meant when applied directly against Japan's industrial and urban landscape. Those missions would soon test both strategy and resolve in ways planners had only begun to anticipate. The transition from preparation to execution became visible in November 1944. On November 24, 1944, the XXI Bomber Command launched one of its first major B-29 strikes against the Japanese home islands from the Marianas. The target was the Nakajima aircraft engine plant near Tokyo, a facility linked to Japan's aviation production. The mission represented more than a single attack. It was a test of whether the new bomber force could deliver strategic results from Saipan. Aircraft lifted off in carefully timed intervals. Each departure consumed long stretches of runway, the heavy bombers rolling under full power before climbing slowly into the morning sky. Crews settled into long overwater navigation. Radio silence was largely maintained. Position fixes relied on celestial navigation and dead reckoning. As the formation approached Japan, weather reports proved accurate but unforgiving. Strong winds at altitude affected timing and fuel use. The jet stream, still not fully understood operationally, pushed against the bombers. Some aircraft arrived over target later than planned. Formation cohesion loosened under the atmospheric strain. Japanese early warning systems detected incoming aircraft. Radar stations along the coast picked up contacts. Fighter units were alerted. Interception attempts followed, though climbing to B-29 altitude required time. Some Japanese pilots reached the bombers. Others struggled against performance limits and coordination challenges. Anti-aircraft fire rose over target areas. Black bursts marked altitude estimates rather than precise tracking. At 30,000 feet, accuracy from the ground was inherently difficult. Still, flak reminded crews that the homeland was defended. Bombardiers relied on the Norden bomb site when visibility allowed. Where clouds intervened, radar bombing methods filled the gap. Results were mixed. Some bombs fell within industrial zones, others scattered due to wind drift and altitude variables. Post-strike analysis would later show that damage occurred but fell short of decisive disruption. Yet the mission's importance lay elsewhere. For the first time, a sustained heavy bomber force based in the Pacific had struck the Tokyo area from secure island bases. The psychological boundary of distance had been crossed. Japanese leadership now faced proof that the Marianas were not merely lost territory. They were active launch points, Crews returning to Saipan reported long hours, headwinds, and the strain of high-altitude operations. Some aircraft diverted to alternate fields. Others landed with reduced fuel margins. Maintenance teams immediately inspected engines stressed by the long flight. Debriefings were clinical. Wind speeds, bomb patterns, enemy response. Every detail mattered for the next mission. Commanders compared expectations to outcomes and began refining tactics. The early raids did not cripple Japanese industry overnight, but they demonstrated reach, and reach changed calculations. Factories that once operated beyond bomber range now required air defense planning. Production schedules had to consider disruption. Resources had to be allocated to homeland protection. Each subsequent mission built on the last. Nagoya, Kobe, and other industrial centers entered targeting discussions. The campaign was still forming its identity, still adjusting altitude, timing, and bomb loads. But a pattern was emerging. These bombers could arrive, strike, and return with regularity. And regularity, in strategic warfare, often mattered more than spectacle. It meant pressure could be applied again and again, forcing responses that drained men and material. By the end of 1944, the air war against Japan had begun in earnest, though its most consequential phase was still ahead. Because commanders were already questioning whether altitude and precision alone would achieve the desired effect under Japan's unique conditions. Those questions would shape the decisions that followed, as the bombing campaign moved toward a more decisive phase. By early 1945, the bombing campaign reached a point of reassessment. Results from high-altitude precision raids were carefully reviewed by the WWII Bomber Command leadership. Photographic reconnaissance, bomb damage assessments, and mission reports showed that while some factories had been hit, the overall disruption to Japanese industry remained limited. Weather, wind drift, dispersed industrial layouts, and maintenance issues all reduced efficiency. In January 1945, Major General Curtis LeMay assumed command of the WWII Bomber Command. His reputation had been built in Europe, where disciplined formations and persistent pressure were central to strategy. In the Pacific, he encountered a different operational reality. Japan's urban industrial landscape, atmospheric conditions, and air defenses required adaptation. LeMay and his staff analyzed patterns. Much of Japan's war production was not concentrated in a few massive factories. It was spread across smaller workshops, integrated into urban neighborhoods. Destroying a single plant might not halt output if subcontracting networks continued elsewhere. The industrial system was interwoven with cities themselves. Altitude also remained a problem. The jet stream continued to scatter bombs. Crews faced long exposure times at high levels with inconsistent results. Every mission consumed fuel, airframe hours, and trained manpower. Efficiency mattered. A shift gradually formed in planning rooms. Instead of focusing solely on high-altitude daylight precision, planners explored lower-altitude night attacks using incendiary bombs. The intent was not arbitrary destruction, but targeting the urban areas where much of Japan's war-related production and logistics were embedded. Japanese cities, with many wooden structures, were vulnerable to fire spread under certain conditions. This was not an impulsive decision. It followed months of data, reconnaissance, and operational review. Incendiaries had been used before in warfare, but their application at this scale represented a new phase in the Pacific Air Campaign. On the night of March 9–10, 1945, that shift became visible over Tokyo. B-29s approached at lower altitudes than earlier missions, reducing jet stream effects and improving delivery concentration. Pathfinders marked target zones. Crews released incendiary clusters designed to ignite multiple points. Weather conditions that night, dry air and steady winds, contributed to rapid fire spread. The resulting fires caused extensive destruction across large sections of the city. Firefighting systems were overwhelmed. Urban density magnified the impact. The scale of damage and loss of life was severe, and later assessments recognized the human cost as profound. From a strictly military perspective, the raid demonstrated that the bomber force could impose large-scale disruption on Japan's urban industrial base. Rail yards, workshops, and storage areas within city zones were affected. The psychological effect was equally significant. The sense of distance as protection was gone. The war had fully entered the airspace over Japan's largest cities. Japanese air defenses continued to resist. Fighters still rose to intercept when possible. Anti-aircraft units remained active, but resource limits, fuel shortages, and pilot attrition constrained response capacity. Night interception at scale proved especially difficult. American planners did not view a single raid as decisive. The strategy centered on sustained pressure. Repeated strikes forced Japan to disperse resources, reinforce defenses, and cope with recovery demands. Each response required labor and material that could no longer be directed elsewhere. For Japanese leadership, the strategic dilemma deepened. Protecting cities, sustaining production, and maintaining field operations all competed for shrinking reserves. The bombing campaign did not operate in isolation. It intersected with naval blockades, battlefield losses, and logistical strain across the empire. By mid-1945, the air campaign had become a constant factor in Japanese planning. It influenced transportation, factory output, and civilian life. It also signaled how modern warfare could reach deep beyond front lines into the infrastructure of a nation. The decisive change was not a single explosion or a single night. It was the realization that the bombers could return repeatedly, adjusting tactics, refining methods, and sustaining operations from secure bases in the Marianas. The fall of Saipan had made this possible. The adaptation of tactics had made it effective. Together, they marked a turning point in how the Pacific War would be fought to its conclusion. And as the raids accumulated, their consequences extended beyond immediate damage, shaping the final months of the conflict. Those consequences would soon be measured not only in destroyed structures, but in shifts of strategy, morale, and the balance of endurance. By the spring of 1945, the bombing campaign against Japan had moved from experimental to systematic. Mission frequency increased. B-29 groups rotated through strikes on industrial zones, transportation hubs, ports, and urban production districts. The objective was cumulative pressure. Each raid alone might be limited. Together, they strained Japan's capacity to repair, relocate, and replenish. Post-strike reconnaissance became a routine science. Photographic aircraft documented burn patterns, blast areas, and infrastructure damage. Analysts compared before and after imagery to estimate disruption. These assessments shaped future targeting lists. Rail yards that remained functional returned to priority. Factories that resumed output were revisited. Aircraft production faced interruptions as component workshops were damaged or displaced. Transportation bottlenecks slowed movement of raw materials. Coal distribution, essential for power and manufacturing, encountered delays as rail networks required constant repair. Even when facilities survived intact, workforce dislocation affected output. The naval blockade tightened these pressures. Merchant shipping losses reduced imports of fuel and ore. Factories sometimes stood ready, but lacked inputs. The bombing campaign amplified shortages already present. It did not operate alone. It compounded existing strain. For civilians, air raid alerts became a part of life. Sirens, blackouts, and evacuation plans were no longer occasional precautions. Many families in major cities sent children to rural areas where possible. Schools and local organizations participated in civil defense drills. Buckets, hand pumps, and neighborhood brigades remained central to firefighting efforts. Yet, the scale of some raids exceeded local capacity. Urban fires could merge into wider conflagrations. Recovery required clearing debris, restoring utilities, and providing shelter. These efforts drew labor away from other wartime needs. The home front became another arena of endurance. Japanese authorities attempted adaptation. Industry dispersed where feasible. Some workshops relocated to smaller towns or rural sites. Camouflage measures increased. Air defense units adjusted deployment patterns. But dispersal reduced efficiency. Smaller sites often produced less than centralized factories. Within the Japanese military leadership, assessments were pragmatic. Reports acknowledged damage without always revealing full extent to the public. The challenge lay in balancing morale with realism. Leaders needed the population to remain steady while confronting mounting pressure. On the American side, evaluations focused on effectiveness per sortie. Planners weighed fuel consumption, aircraft wear, and crew fatigue against measured disruption. The goal remained to shorten the war by reducing Japan's capacity to sustain it. Every mission was framed within that broader strategic calculation. Airfields in the Marianas operated at high tempo. Maintenance crews worked continuously to keep aircraft serviceable. Engines were inspected, replaced, and modified. Spare parts flowed through supply lines that stretched across the Pacific. The bomber force represented not just striking power, but logistical persistence. Losses occurred on both sides. Some B-29s failed to return due to mechanical failure, weather, or enemy action. Each loss meant trained airmen gone and aircraft that required vast resources to replace. The campaign's scale did not erase its risks. Still, by mid-1945, the overall trajectory was clear. The bombing campaign had become a sustained element of the war's final phase. It influenced planning at the highest levels and daily life on the ground. And as reports accumulated, both nations understood that the air war was shaping the conditions under which the conflict would eventually conclude. Those conditions would grow clearer as the consequences extended into strategy, diplomacy, and the final decisions of the Pacific War. By the summer of 1945, the cumulative effects of the air campaign were visible across Japan's economic and military landscape. Urban industrial output had declined in several sectors. Aircraft manufacturing, already strained by material shortages and skilled labor losses, faced further disruption when component workshops were damaged or relocated. The decentralization of production, intended as a safeguard, often reduced efficiency and coordination. Transportation networks struggled to keep pace with constant repairs. Rail lines, bridges, and port facilities required repeated restoration after raids. Fuel remained one of Japan's most critical vulnerabilities. Even before large-scale bombing of the home islands, submarine warfare had cut deeply into tanker traffic. As refineries and storage facilities faced attack or precautionary dispersal, distribution became more difficult. Aviation fuel for pilot training and interception missions grew increasingly scarce. Some units limited flight hours to conserve reserves. Military planning reflected these realities. Defensive priorities shifted toward homeland protection. Fighter deployments were adjusted to guard key regions. Anti-aircraft batteries were reinforced where possible. Yet every resource devoted to defense was a resource not available for offensive operations elsewhere. For civilians, adaptation continued. Evacuations from major cities increased. Local governments organized labor for debris clearance and firebreak construction. Neighborhood associations often took responsibility for immediate response after raids. Diaries and local records from the period describe routines shaped by alerts, rebuilding, and uncertainty. Despite hardship, social order generally persisted. Public messaging emphasized perseverance and collective effort. The state sought to maintain continuity in administration and production even as pressures mounted. The population was not a passive observer, but an active participant in wartime endurance. From the American perspective, strategic bombing was one part of a broader framework. Naval blockades restricted imports. Ground campaigns in places like the Philippines and Okinawa tightened the perimeter around Japan. Long-range fighters, such as the P-51 Mustang, once bases in Iwo Jima became available, began escorting some B-29 missions and conducting their own sweeps. Air-sea rescue operations also improved survival chances for downed crews. By mid-1945, U.S. planners debated how air power might influence the timeline of the war's conclusion. Some assessments suggested that continued bombing and blockade would further degrade Japan's ability to fight. Others recognized that predicting political decisions under wartime conditions remained complex. What was certain was that the strategic environment had changed since 1944. The capture of Saipan had enabled a campaign that reached deep into the Japanese home islands with regularity. The B-29 force had evolved from a new asset into a sustained instrument of pressure. The bombing campaign did not act in isolation, and it did not single-handedly determine every outcome, but it shaped the context in which final decisions were made. It affected industry, logistics, defense planning, and civilian life. It demonstrated how air power could compress distance and bring the realities of war to a nation's core territory. As the war moved toward its final weeks, the sky over Japan had become a contested and consequential space. The consequences of that shift would be studied long after the engines fell silent. And in the quiet that followed the war, historians and participants alike would look back at Saipan as one of the moments when the geography of the conflict fundamentally changed. That reflection opens the final chapter of this story, where the meaning of these events extends beyond dates and targets into the broader history of modern warfare. The story of the B-29 campaign from the Marianas is not only about machines, targets, or tonnage dropped. It is about how distance, once the greatest barrier in the Pacific, was steadily erased by technology, logistics, and planning. Before 1944, the Japanese home islands sat far from the main arcs of combat. Battles were fought on reefs, in jungles, and across seas that seemed to buffer the mainland from direct attack. The fall of Saipan quietly ended that separation. A small island in the Pacific became a hinge of history, turning the war's geography inward. Air power did not replace armies or fleets, but it changed how pressure could be applied. It allowed a nation to reach beyond shorelines and strike at systems that supported war itself: factories, railways, storage depots, and ports. It also carried the weight of human consequence, where civilians and soldiers alike lived under the same sky. For the air crews, the campaign demanded endurance across immense distances. For those on the ground in Japan, it introduced a new form of vulnerability. For planners and leaders on both sides, it forced difficult calculations about strategy, resources, and time. In the years after the war, analysts would study these missions as part of the evolution of modern warfare. The lessons extended into Cold War doctrine, aerospace engineering, and the ethics of strategic bombing. They shaped how nations thought about reach, deterrence, and the meaning of security in an age when oceans no longer guaranteed safety. The engines that once thundered off Saipan's runways are silent now. The airfields have returned to quieter purposes. Yet the historical echo remains, a reminder that technology can redraw maps, and that moments on small islands can ripple outward into global consequence. The sky over the Pacific, once a barrier, had become a bridge, and through it, the course of the war was irrevocably altered.